And with that, I'm going to present the last speaker for this session, Vincent, who is with Roche and Genentech, who's going to talk about the exciting work that they're doing. We're going to go probably 10 minutes past the 2 p.m. timeframe, so we'll go for the next 20 minutes to take a 10-minute break, and then we'll pick up with the final session for today. So with that, Vincent, it is yours.
Thank you, Phil. Yeah, let me figure out the sharing options here. Then I will go share the screen.
I can see it.
Okay, all right. Let me drag it over. So you can still see it, right?
That's perfect. Yep. Looks great.
That's in. Okay, so that's in slideshow right now. Okay, cool. Hi everyone. Happy to be here, joining this Gen AI in Pharma session for this year. Today I'm going to talk a little bit about our current efforts for building the AI an assistant for our programming. We leverage some multi-agent framework, and we customize it using this framework. And we recently just launched it to production for our internal users. And I'm going to share our story for building this little tool. So here's a quick agenda for today. I'm going to explain some rationale behind our development journey, and also going to share a little bit about our architecture of AIR. And then we are going to do a quick demo. This is a pre-recorded video. And then we're going to talk a little bit about the next steps that we're going to take. So why do we want to build our own R coding assistant? As many of you know, that we on the market, we have already got a lot of coding assistants, and probably too many. But you know, like we have some very cool and very powerful general purpose AI coding editors. Just to name a few, I think the top players are Cursor, Copilot, Windsurf, and those tools. And also, you know, using these tools, you can also call different kind of very powerful foundational large language models, you know, like Cloud, Gemini, and GPT models. And you know, like these tools are very, very powerful for general purpose coding. If you consider coding as a whole, like across all the industries as a task to tackle, and these things provide you very good general purpose supports for these tasks. And then what is missing? From a pharma industry or from a clinical insights generation perspective, we feel like we have a lot of the knowledge on our internal tools and processes that we currently can't find or can't see in those public models. And the deep understanding of clinical insights generation seems to be a little bit missing as well. I can give you one example. If you think about the coding process or coding experience in the pharma industry, which we have been using SAS for, I don't know, like maybe 20 years or plus. And we have been dealing with these, what we call like CDIS compliant data structures, and all these things combined in the pharma industry. This only consists of a very tiny part of all the general purpose coding. If you consider all the tech companies, what they do for coding, what all the, you know, like the retail industry, what they do for coding, what finance industry they do for coding, like this pharma industry, like the coding in this specific industry only consists of a very small, tiny piece of all the coding activities that we do every day across all the industries. So those foundational large language models, they definitely have knowledge about, you know, the coding in pharma. And definitely they also have knowledge about coding in retail or in finance. But a lot of the knowledge, like the deep understanding of the clinical studies, deep understanding of the insights generation for the clinical trials are not really covered well in those models. Another very important piece is we really want to have an instant refression knowledge base. As you all know, these models have been released, I think, more and more frequently, but again, they were based on some kind of a data cut. While you do have the web search, you know, functionality right now with all these leading models, but you know, to embed some internal latest process information into the model, it remains a very big challenge for a lot of the use cases that we have in pharma industry. So what we hope to have is to build an AI coding agent that is able to know or make use of the internal knowledge or the process we have at Roche when people are doing these coding activities. And we would really want to integrate those with like the little agent that we build with those commonly used coding editors. Because we're not going to reinvent the wheel to build our own copilot or cursor, or we're definitely not going to build those large language models ourselves either. But we hope that the tool that we build could be self-adaptive, and also it require minimal manual maintenance moving forward. So that to the third point that I show in the previous notes, that we hope the knowledge could be refreshed almost like automatically or semi-automatically to allow us to continue using these tools moving forward. So to make to build our tool and to really realize these ideas, we started exploring the possibility to build AIR. This is really an AI assistant for our programming. And we're going to talk a little bit about the architecture behind AIR and how did we actually achieve the goal here. So first, AIR is a multi-agent system where individual agent is responsible for a single R package. Agents dynamically hand off controls to one another based on their specializations. And one agent, they could utilize the entire R package documentation for a specific R package. And this definitely covers all the function manual, vignettes, other documentations, and even examples, and all these things that the package developers put into the documentation. The agents are also equipped with a set of tools to get additional knowledge. I'm going to explain this later while the demo, as well as I have a visualization of the architecture on the next slide as well. The system is also self-adaptive, where the agents could dynamically get created when needed, and they actually get created based on the user question. And the created agents are actually cached and shared across users. So let's say if I ask the question about ggplot2 and later on someone else asks a similar question about ggplot2, maybe the request is different, but it also refers to the same package. This ggplot2 agent is actually shared with the other user, so they could leverage that existing agent to answer their question as well if it's about ggplot2. The agents are created using the most recent data. So we leverage the current packages where the R universe from the R open site. So there is an API behind it so that you could grab information for all the latest R packages published to CRAN, and you get all the function manual, vignettes, and all the different components of the documentation. And really, there is no cutoff date or manual management of this knowledge base if you think about this public CRAN domain. And we also cover packages on private domains, like basically Roche internal packages that we use and that we don't open source. We internally manage all the R packages, obviously using the Posit Package Manager, and we find a way to extract information from there and then build or enhance our database of our packages using our private repos as well. And another good architectural feature of AIR is that we actually managed to copy paste the suggested code from the AI to the webR window. I'm not sure how many people are familiar with webR, but later on you're going to see in a demo. This is also in a collaboration with Posit that they share with us that it is possible to actually send some of the code that's suggested by the AI to the webR, or like a window that we can embed into the tool or the UI. So it's very easy for user to execute the code to see if it's good or bad, or like they can also make some edits to the code. I'm going to show you really quickly later in the demo that how this is helping the users. And this entire system of AIR is built as a fast API service, which means that it could be used in a variety of scenarios. Right now, we launched to our main user base of AIR as a UI. So it's kind of like a chatbot. So you interact, ask a question, get an answer. but we also already allow this to be used as an API that connect to, let's say, Cursor or Copilot, or even used as an MCP service that, like you don't really have to rely on the UI, but, if for some advanced users, they would like to embed this into their VS Code or other tools, that they can already do that. So this is a visual representation of what I just described in the previous slide. So you can imagine there's a user who asks a R-related question. And then the first thing that the AI is going to do is to have what we call an R-expert agent as the first stop to evaluate this question. So this R-expert, we feed this some system message so that it knows that it's actually an R expert, and it can answer some of the very general R questions already. Or if it feels like this is a question that it cannot answer directly, it will then pass the question to what we call an agent package identifier. So let's say if the question is about ggplot2, and then the R expert will basically call a tool to identify this ggplot2 package, and then pass it to the next agent. And then this agent will then figure out, okay, this question is actually about ggplot2, and then it actually has a pool of cached package agents, or in some cases, if this is a question about really a new package that is not yet cached, it will build an agent on the fly to try to answer the question. So it actually grabbed the information. Let's say if it's about a new package that's nobody really asked before, it actually grabbed that information on the fly from our open side, or maybe from internal Posit Package Manager, and then build that agent to try to answer that question. So in this case, that agent package number one will try to answer the question and then provide the answer to the user. In some cases, the question is going to be about multiple packages. So in that case, the package identifier will try to analyze the question, the user question, and then leverage multiple agents to collaborate to try to answer this question. So these two agents now maybe covers a bunch of multiple packages, and they're gonna answer the question using their own knowledge. And then they're going to pass those answers into what we call an agent synthesizer to try to synthesize the answer before they actually return the answer to the user. So I'm going to show you a quick demo. This was some video snippets that we recorded for our tool. So this is a landing page. I'm just going to talk through this while I play this. So if you go to this main page, you're going to see a number of simple questions. And here, I think the first example we want to show is that we ask actually in a very general or basic R question, how can I create a scatter plot using base R? This is a very basic question. You don't even need to build an app to answer this question. You can use any AI tool to do that. But what I'm trying to show you here is this agent R expert is trying to answer the question directly. So it doesn't really call any of the tools or agents to try to answer this question. And here, this webR, this is what I mentioned to you earlier. You can actually execute the code from this AI from this example, and then you can actually modify the code here in this extracted code snippet, and then you can see the plot. So this is kind of like a mini RStudio type of thing in your browser that's embedded here, and the code is automatically pasted to this editor here. So that's the first example. The next one is about a question about the single R package. So here, I think the previous one we showed that the R expert actually directly answered the question. Here we ask a question about GPT summary, which is how we could create a summary table for regression model results using GPT summary. So obviously you have to know how to use this package to do this or to complete this task. So this R expert, well, this is the answer that it actually leveraged the table regression, which is this is a correct answer. But if you look at the agent conversation details, you can see that the R expert is trying to call a tool to enable to transfer the question to another agent, which is the GT summary agent, right? So and then this GT summary agent, this thing, because this is a single package question, it will try to answer this to complete this task using its knowledge about GT summary. So and then obviously you also have this webR window at the very bottom, and then you can run the code. And I just didn't include this in the demo, but GT summary is a public package, so that you can also try that code in the webR window embedded there. So now let's try some question. Let's try some question about the internal package. Okay, so as you can see in the sample questions, we actually included some of the packages that's not open, that are not open source. For example, Amiro Roche. This is a Amiro extension package that leverages some of the Roche internal standards and templates and those kind of things. So it's really kind of like useless for all the other companies because this is Roche standard. So we don't really want to open source these things. And also there are also other packages that are listed out in the sample question that are internal. And here I'm gonna show you when we test this with a sample question here as how to use read DAPM3 function from Amiro Roche. For those who don't know, like DAPM3 is basically your atom data specification, which it lists out all the derivations you need to do for your atom data sets, and then like the variables that you need to derive and the rules that you need to follow to derive those variables. And here you can see that it gives you the answer leveraging the Amiro Roche package. But if you look at this conversation detail here, this R expert will transfer the knowledge or transfer the question to the other agent called Amiro Roche. This is not public package. So basically behind the scene, we actually link this up with the POSIT package manager so that people, so that the agents is aware of all the internal packages that we have hosted on our server. So I think that's about this example. The last one is really about a question about the multiple packages, right? So in many cases, people are going to ask questions about how can I do this using package A and B, right? So here, just to continue the conversation from GT summary, we want to create a readout data set or ARD for readouts from, let's say, in a survival model. And then I want to use CARS and CARDX, which are the packages for creating analysis results data sets in R. And apparently I mentioned two R packages in the prompt, so CARS and CARDX. So let's see how this bot is going to react. This is a very long answer, as you can imagine, because it was trying to use both packages to answer the question. But if you look at the conversation details here, very interesting. Like the agent, the R expert noticed that, okay, I need actually two packages to answer this question. So both CARD and CARDX agents are going to be called. And then both agents are going to try to answer the question. And at the very end, there is a synthesizer to try to synthesize the answer and then return it to the user. So you can see like you can follow all these steps, and obviously you can use webR to try your code because both packages are also on CRAN. So I think that's the demo. Just really about our next steps. The first thing we want to do is right now this tool, the first release of this tool is really just leveraging the package documentation. What we hope to achieve is we have a lot of code examples. We have the process documents, some internal standards, and even best practice documents that we could potentially leverage in build as tools for the agents to leverage to answer the question, to provide a more comprehensive answer to some of the questions. Next thing is we hope to customize the API to allow the integration better with the IDEs, for example, RStudio or potentially Positron. Specifically, we want to enable code completion within the IDEs. As you know, like you could have these features using, for example, GitHub Copilot. But as you can imagine, like building APIs to do code completion is slightly different to build code. These little AI or AI chatbots for coding application or coding assistance, because for code completion in your IDE, you basically just want the bot to return code, or let's say comments related to the code. You don't really want it to explain in very detailed about all the like the rationale behind why the code is written in that way. So there's some tweaks that we need to do to enable this feature in IDE that's under development right now. But obviously, people can still use this as an independent UI. And the third thing I think we really want to do is to digitize our metadata to enable our workflow automation. So coding assistant is just one piece of basically just help you to write code, right? So, but we also want to leverage all the other components or other agents that we could potentially build and try to build the entire workflow. And writing code is just the one piece of that. And to do that, you have to build or spend a lot of efforts on digitizing your metadata so that agents could be able to leverage. I can give you one example that we were trying to incorporate a lot of the code examples that we are currently building with GT Summary. And we're trying to build our catalog, or like the example catalog of GT Summary to make it more, metadata ready, or like it's completely digitized, so that it could be the different components of that code examples could be used for different purposes, or for us to train the bot, for us to build the downstream agents to complete our coding tasks. I think that's all I have for today.